Okay, so version 2, question 2. We're looking at a men's high jump world record. We are told that it's got an exponential model. Important things, h is height above that in centimetres, and t is years since 1970. So years since 1970, 1971 take off 1970, got 1. One thing you will need to notice is these don't go up in equal sized jumps, because some years the record wasn't broken. Height above 2.24 in metres, and then convert it into centimetres. So 2.29 take off 2.24 will give you 0.05, which is 5 centimetres. And then for our last column, you can, on your calculator, just type in ln 5 and it will give you this value. Okay, so first part of the question, we are asked to show that this can be rearranged into this. This used to be a really common question but hasn't come up quite so much recently. So we start off with what we've been given. We ln both sides. You can separate two things that are times together and they'll turn into an add thing. So ln h is going to stay the same. We can separate ln a and ln e to the kt. We then need to know that these two are inverses, so we'll cancel each other out. So you've got ln h equals ln a plus kt. Useful things to know on there. That is going to be your y-axis. That is going to be your plus c, so that will be your intercept. This is going to be your gradient, and this is going to be your x value on your x-axis. So plot the graph, draw the line, and then we're going to need to calculate a and t. So from looking at your graph, you should be able to work out a gradient. So the gradient is going to be k, and that's going to come from change in y over change in x, and that should be something around 0.0767. Everybody's line of best fit will be a little bit different, so everybody's value of k will be a little bit different. And that is for part C. The other thing that we're asked to find out is a value of a. Now our intercept is going to be ln a, and reading that off the graph, it comes in at about 1.58. So if we want to know what a is, that's going to be e to the power of, and then we can have a value for a. We then have a question of express h in terms of t. So what that's telling us is the only letters we are allowed in our equation are h and t. So if we look back up at our original equation, we can substitute what we know into it. So for part C, again, clearly weird numbering, we've got h equals A, which is 4.85, e to the power of k, which is 0.0767 t. Okay, so use your equation to find the expected world record height in 1993. So, first off, we are going to need to know what our value of t is, and it's years since 1970, so 1993 should be 23, and we want to find the expected height, so we can just substitute it into this equation, and we end up with h equals 4.85 e 0.767, and show that you've substituted your 23 in. You can then stick this into a calculator and get an answer. Now our answer comes in at this, but this is the number of centimetres above 2.24 metres, so that gives you an actual height of 2.24 plus 2 plus 0.283. So that's if we put them both into metres. So hopefully that will give us a height of 2.52 metres. Okay, so last bit. The actual height achieved in 1993 was this, and what we want is a percentage error. So percentage error, we are going to need to know. So percentage error is the modulus of our prediction minus the actual value divided by the actual value and times by 100, and that should come in at 2.86%.